Hello and welcome to Paydirt TV. I'm Dominic Piper. Today I'm joined by Chris Reed, Managing Director of Neometals. Chris, thanks for coming in.
Thank you very much for the opportunity, Dominic.
Chris, it's really a remarkable story, the Neometals one. 5 or 6 years ago, if we'd done this interview, we would have been talking a classic WA Junior Explorer with a number of gold and base metals prospects here in Western Australia. But now, I mean, I don't even know how to describe the company. You're a tech company, you're a recycling company, you're a battery minerals company. How did you make this leap from Junior Explorer to process technology company?
Yeah, sure. Look, I mean, we decided to go into lithium in 2009 and secured the rights over the Mount Marion lithium project. We did a deal with Mineral Resources in 2009 to develop it, started developing it in 2010, had to stop in 2011 for a price war and a couple of years, where we developed a few processing technologies that would enable us to operate at lower cost and be integrated to produce lithium chemicals rather than spodumene. And then in 2014-15 the market turned, the spodumene price went up. We did a deal with Ganfeng and got that asset into production. When the MinRes guys were building Mount Marion 2016, we started looking at what was going to be the next most positively impacted commodity out of this battery transition, and it was cobalt. We found that the best way to get the cobalt was to try to recycle and recover the cobalt from lithium cobalt batteries in consumer electronics. So we started doing that and then worked out that the real volume was going to be in EV batteries that were more complex, that had nickel, cobalt, manganese, aluminium and other metals in it. And we entered into what's been a pretty successful R&D journey that's led us to the point now where we're trying to develop one of the leading battery recycling businesses in the world with a very strong German partner. So necessity is the mother of invention.
I watched your presentation at the recent Paydirt Battery Minerals Conference, and it is a remarkable story now that you're really at the cutting edge of this recycling movement, if you will, in Europe. What's your approach there? Can you explain how you take an EV battery and produce a saleable product for EV?
Yeah, sure. So essentially the first stage is similar to a concentrator in a traditional sort of base metal. We take the battery, we shred it, we separate out the copper and aluminium foils, the plastic separators, any casings that it might have, be they plastic or steel. And that leaves us with the black mass, which is a powder that comprises the graphite anode, which is the negative side of the battery, and the cathode, which is the positive side of the battery, and that's generally an alloy of nickel, cobalt, manganese, aluminium, what have you. We then put that into a sulfuric acid solution, and then we solvent extract out the various individual base metal sulfates. The lithium comes out initially as a sulfate, and we convert that to carbonate or hydroxide as the customer wants, and we're left with an ammonium sulfate tail. That's courtesy of us using ammonia in the process as opposed to sodium, which is a fertiliser. So it's a pretty elegant solution, solvent extraction, pioneered in Queensland at Mount Isa. So it's a pretty well-known technology. We've just applied it very, very early. I mean, we brought up when our move into recycling in 2016, 2017, people looking at us going, well, why in God's name would you do that? And we're saying, well, we are going to need it. I mean, we know that there's more EVs coming. There's going to be more batteries. So we knew the demand would go up. But what we're even more confident about is that these batteries wear out. And they wear out quicker than you think. So there was an unfulfilled need, and hence why we developed the battery recycling tech.
I imagine that fits in very neatly. I know you've built a demonstration plant and you're doing a lot of your R&D now in Germany. I assume that fits neatly into the European desire for a circular economy and a low carbon way of capturing these minerals.
Yeah, absolutely. They're great tailwinds. I think if we have a look at why we deployed into Europe first, outside of China, Europe has the largest production hub of batteries, closely followed by North America, the US. So hence why we've done, initially we put our demonstration plant into Germany. We've now upgraded that capacity and we formally opened our first commercial battery disposal operation for these batteries last month. and we've done a deal with Stelco where we should be making a decision in the September quarter on our first plant in North America.
So how will you use these plants then? Will you license them out? Will you run them for other companies? What sort of is the commercial agreement?
So we've got flexible business models, and that's one of the things that's really appealed to the market. So at the moment, whilst the new battery regs in Europe don't force you to do fully integrated recycling yet, that's probably not coming till sort of mid-decade. It's more around safely disposing of the batteries at the moment, and that's what we do. So they give us the batteries for a fee. We dispose safely, deconstruct them and sell the materials. We're not doing the full refinery and closing the loop. We will, but just not at the moment. So that's offering a recycling as a service. For people that have got larger volumes, for example, car makers or cell makers, we'll look to do joint ventures. So we're looking to do that joint venture with Stelco in North America. They want to. They're transitioning their steel business from sort of magnetite pellets to electric arc furnace, so it needs scrap steel. More cars, more batteries. So a joint venture with them will see us deploying a spoke and hub network. So joint ventures for people that have got volume, and for the really, really large guys. So, we've done that deal with Mercedes-Benz. We're going to, or they've announced it, we're going to put in a 10-tonne a day integrated operation for them and enter into a collaboration for a period of 5 years so that they can understand everything about recycling, and then they've got to make a decision on what they want to do. Now, we'll either do them as joint ventures or for something that's that big where they produce 2.5 million cars. Now, if they're going to be majority electric, they're going to need, 800 to 1 million tonnes of capacity. We're pretty comfortable licensing the technology, but we'd build the plants for them.
And this sort of new regard for recycling and the European fundamental need for raw materials extends Neometals business now beyond lithium and the batteries themselves into vanadium. You've struck a deal to process vanadium, steel slag in the Nordic countries. Tell us a little bit about this project.
Sure. Well, the battery recycling is for portable electric storage, right? So the EVs or consumer electronics. The vanadium recovery is really for stationary energy batteries, right? The vanadium redox flow batteries, where the electricity is stored in vanadium solutions. So yeah, we've done a deal there where we're earning into a joint venture with Critical Metals, and it's underpinned by a 2 million tonne slag purchase agreement with SSAB, the highest grade vanadium bearing slags in the world. We've developed a process that uses captured CO2 in the leaching. We then use solvent extraction to pull out the vanadium and other technology. Obviously, we've got some deep skills in that now. And a traditional vanadium back end, ammonium metavanadate, and produce a V2O5, that can go straight back into vanadium electrolytes for the batteries. So that's taking a waste product, recovering a battery feedstock with a negative CO2 footprint, because we're capturing CO2 from emissions, using that in the leaching solution. And we've signed a letter of intent with Betalar, which is a Nordic company that wants to use our material, our tailings product, which is a carbonate and inert, in green cement. So I mean that one really does tick all the boxes.
And then, not finally, but certainly the third spoke to the wheel in Europe is the application of that the Eli process that you developed with Minres all them years ago, and you've set up a facility in Portugal, I believe.
Yeah, we're in the process of ordering the pilot plant at the moment. We're going to put the pilot plant at a company called Bondelti, which is Portugal's largest chemical producer. So essentially our technology that we own 70%, Minres own 30%, which were the original Mount Marion shareholdings. It's an adaptation of the chloralkali process. So instead of running electricity through a sodium chloride solution, we run it through a lithium chloride solution to make lithium hydroxide directly. So big capex and opex savings with a very simple process. And so we're looking at deploying that into Europe with a chloralkali producer, because that's what it needs. So we're co-funding a pilot plant, and we'll test various brine solutions with we've piloted it on Argentine, Chilean grinds, Mount Marion spodumene. We've even run through some Greenbushes spodumene, so it's a pretty robust process. And I mean that alone will slash the CO2 footprint of lithium production, because you don't have all these reagents, where you're bringing soda ash and caustic soda, thousands of kilometres.
This entire business proposition from Neometals seems to play into that thematic of low carbon emissions and reduced environmental issues. Are you seeing a new class of investor being attracted to the company because of that?
Yeah, sure. I mean, our customers and moving away from traditional gold, where you just threw it over a fence and money came back, you actually got to listen to what your customers want when you move into industrial minerals and advanced materials. So, what they've told us is, they need access to those materials. Accessing it from their own waste is good for these guys, but doing it in a greener manner. So everyone has got to show their customers, whether it's the car maker, the cell maker, the cathode maker, the miner, we've all got to show each other a pathway to lower carbon, because the end product now is going to have carbon stickers on it. Instead of fuel consumption, you're going to have CO2 declarations on every product.
Chris, it's a fascinating story, and Neometals is really at the vanguard of Australian development of these technologies and these processes. Thanks very much for joining us, and hopefully we'll be able to get over to Europe someday soon and have a look at each of these projects.
Absolutely. Thanks a lot, Dominic.